Hello, class. Well, today we're going to be talking about systems word problems, okay? And these are going to be the last top. This is going to be the last topic we talk about here in our unit on systems of equations. Okay, these notes are going to focus on problems where one equation is in the form of ax plus by equals c, where a, b, and c are constants. Okay, so at least one of our equations is going to look something like this. It is helpful to think about what is being measured. Okay, so a lot of times you're going to have, well, you're always going to have two equations, but if you think about what's being measured, it's easier for you to write the equations. Okay, they're usually two different things being measured, like items and value, or amount and total cost, or total price. Okay, and we're going to take a look at a few steps, and of course, we're going to look at a bunch of examples. So our first step in these problems is going to be read the problem, underlining important information. Okay, these are all going to be word problems. You got to make sure you do a very good job. You're careful in reading and underlining the problem. Sometimes there are going to be numbers hidden in the problem, and they're not going to look like numbers. They're actually going to be words. Okay, the next step is going to be define your variables. So you're going to say that X is the number of large cars and Y is the number of small cars, or X is the number of pennies and Y is the number of nickels, something like that. So just so you know what you're talking about. Then you're going to write two equations that define the situation. And again, you're going to want to go back to the first step here and look at the important information that you underlined, and then make sure your equations represent what you underlined. Okay, if you're looking for two things that are added together, make sure you have an addition problem. If you're looking for the difference, make sure you have a subtraction problem, things like that. Then we're going to solve the system of equations. This is usually going to be elimination or substitution. Okay? The way these problems set up, elimination or substitution are probably going to be your best bets for solving these. Okay, graphing, I suppose you could, but it's probably not going to. The problems usually don't lend themselves to graphing. And then finally, we're going to check to see if your answer makes sense. Okay, many times you can't get a decimal or fractional value. So if you're asked for the number of cars, you shouldn't get like 2.375 cars. Okay, it's either going to be 2 or 3. Okay, if you're asked for the number of hours, I suppose you could end up with a fractional number of hours there. Most of these are going to end up with integer answers. So make sure your answer makes sense. If it's not something you can get part of something, then make sure your answer doesn't end up with a fraction or decimal. Like you can't get half a nickel or 2/3 of a quarter. Make sure that your answer makes sense based on the context of the problem. Okay, that's it. Let's get into a few examples. Okay, adult tickets for the High School Musical sold for $3.50, and student tickets sold for $2.50. 321 tickets were sold altogether for $937.50. How many of each kind of ticket were sold? Let's take a look here. So I can see here that I've got two different types of tickets. I have adult tickets for $3.50. I've got student tickets for $2.50. And I've got 321 written out. Okay, I know this is 321. Okay, sold all together. So if I define my variables, I'm going to say X equals adult, Y equals student, yeah, man, having a little problem today writing, student, okay. I'm going to write my two equations now. Okay, so I know if I look at the cost or the price, I know that 350 times the number of adult tickets, so 3.50x plus 2.50y equaled, well, the total price was $937.50. Okay. Now, if I look at the total number, okay, total number sold, I know that if I add my adult tickets plus my student tickets, we sold a total of 321 tickets. Okay, and that sets up our system. Now I'm going to go ahead and solve this using elimination. Okay, if I take this bottom equation here, I'm going to multiply it by negative 2.5. Okay, I'm going to cancel out my y values here. Doing that, that gives me negative 2.5 x minus 2.5 y equals, well, 321 times negative 2.5 is 802.5. Okay, and I'm leaving off the zeros just for clarification. So now I don't have this equation anymore because I went ahead and multiplied everything through. Okay, using elimination, adding these right down, 3.50x minus 2.5x equals 1x. Wonderful, that makes things easier. The y's are going to cancel out, and that leaves me here with 837. Sorry, this is actually a negative. 937.5 minus 802.5 gives me 115. Okay, so that tells me I have 115 adult tickets. Okay, 115 adult. Okay, I'm going to use this bottom equation here, x plus y equals 321, to solve for my second variable. And I can see that the 115 plus y equals 321. Subtracting 115 from both sides, that gives me y equals 206 student tickets. Okay, I feel pretty good about that one. I don't have any fractions, I don't have any decimals, so that looks really good. Okay, let's take a look at the one here at the bottom. Ayana has $2.35 in nickels and dimes. If she has 33 coins in all, find the number of nickels and dimes. This is a classic kind of word problem for systems. Okay, a couple of tricks you got to watch out for here. So I'm going to say that X is my nickels and Y is dimes. Okay, and I have a total of $2.35. Now, if I'm looking at the total value here, I know a nickel is worth 5 cents. Okay, and a dime is worth 10 cents. Now you got to be careful because this here is in dollars, and I just defined these in cents. So I want to say that this is actually 235 cents. Okay, be careful, otherwise you're going to get your total value wrong. Okay, so I can say that I have 5x plus 10y equals 235. Okay, and I know I have 33 coins in all, so I have x plus y equals 33. Okay, so again, looks like I'm gonna have to use elimination. I'm gonna go ahead and multiply that bottom equation here by -5. Okay, multiplying this through by -5. Okay, I'm gonna eliminate my x, my nickels here. So that's gonna give me -5x minus 5y equals negative 165. Okay, so now I can go ahead and add my equations here. Okay, I don't have this one anymore because I multiplied it through. 5x minus 5x, that's going to cancel out. 10y minus 5y gives me 5y. And 235 minus 165 gives me 70. Okay. Now I divide both sides here by 5. Sorry, not by y, by 5. And that gives me y equals 14. Okay. So y equals 14. I can use that second equation here. I can say that x plus 14 equals 33. Okay. Subtract 14 from both sides. Boom. X equals 19 nickels. And of course, these 14 would be the dimes. Okay, so there you go. Make sure that when you write your equations, you don't use 2.35. Okay, if you're going to use 5 for the value of the nickels and 10 for the value of dimes, make sure you use 235 for the total value. Same token, if you had quarters, you'd use 25. If you had pennies, you'd use 1. Okay, so make sure you're comfortable with those. That's something you are expected to know just from living in the United States at this point. Okay, Alexa is going to a carnival that has games and rides. Each game costs $3. Okay. Each ride costs $4. She spent $54 altogether on 15 games and rides. Okay, so I'm going to define my variables here. X is going to be games. Sure, why not? And Y is going to be rides. Okay. If I look at the total cost, games were $3 each, so 3x. Rides were $4 each, plus 4y, and she spent a total of $54. Okay. She went on a total, together she had 15 games and rides. So I know that x plus y equaled 15. Okay. Again, I'm going to solve this by elimination. Okay, I'm going to multiply this bottom one here by -3. I'm going to get rid of my x term again. So doing that, that gives me negative 3x minus 3y equals negative 45. And again, I could have multiplied by -4 and eliminated my y, but I'm just going to use the x term here. 3x minus 3x, that eliminates, that goes away. 4y minus 3y gives me 1y. Beautiful, love that. That's going to give me my answer straight away. Equals 54 minus 45 gives me 9. Great, so that was easy. So I know going to my second equation, so that was y is 9 rides. I go to my second equation here, x plus y equals 15. That's going to give me x plus 9 equals 15. Okay, subtract 9 from both sides. Nice little one-step equation here. Boom. X equals 6 games. Okay, easy peasy, easy peasy. Okay, let's take a look at this next one here. Dominic went into a movie theater and bought 2 drinks and 5 candies. Whew, I'm gonna have a tummy ache. 2 drinks and 5 candies, total of $29.25. Colton went in and bought 8 drinks and 7 candies. He's really gonna have a tummy ache. $61.75. I want to know why these kids are running with so much cash. I'm just saying, that's a lot of, whew, wow. Anyway, determine the price for each drink and the price of each candy. Okay, so if I say X is drinks, Y is candy. Okay, so let's take a look at Dominic. Dominic bought 2 drinks and 5 candy and spent $29.25. Okay, Colton went and bought 8 drinks and 7 candy, and he spent a total of $61.75. It's a lot of money for a night out with the movies. Anyway, so there are my 2 equations. Let's go ahead and we're going to use elimination again. Looking at these, the easiest one to get rid of here is going to be our x, okay? Because I've got a 2x and an 8x. If I multiply this top one here by -4, okay, that's going to be your best option, okay? Doing that, that's going to give you -8x minus 20y equals -$117. Okay? So, adding these up now, okay, this top equation is not there anymore because I multiplied it. X's go away. 7y minus 20y is -13y. Okay, don't worry, our signs are going to take care of themselves. Equals 61.75. Going to give us -55.25. Okay. Now, if I go ahead and divide both sides here by 13, sorry, by -13, I get y equals 4.25. But wait a second, I got a decimal there. Is that okay? Yeah, because we're looking for the price of each drink and the price of each candy. Okay, so 4.25. Well, I think it's extraordinarily high. That's a legitimate price. Okay, you can pay $4.25 for something. Okay, so now we're going to take this. I'm going to substitute it back into. Let's use that first equation. Okay, let's use that first equation. So 2x plus 5 times 4.25 equals 29.25. Okay. That's going to leave you with 2x plus 21.25 after you multiply that out equals 29.25. Subtracting 21.25 from both sides. That gives us here 2x equals 8. Divide both sides here by 2. You get x equals $4. Again, while it's extraordinarily high, it's a reasonable answer for this. So each candy was $4.25. Each drink was $4. Okay, a lot of work on those two. Let's take a look at a couple more. Okay, here we go. A group of college students are going to a lake house for a weekend and plan on renting small cars and large cars. Each small car can hold 5 people, and each large car can hold 8 people. A total of 5 cars were rented, which can hold a total of 34 people. Okay, so determine the small cars and large cars. So define our variables. X equals small cars, and y is going to equal our large cars. Okay, so I know that looking at the number of people, 5 times the small cars plus 8 times the large cars equal 34. Okay, I also know they had a total of 5 cars. So I know that x plus y equaled 5. Okay, I don't know why none of these people actually had a car of their own, but that's not part of the problem. So Going to go ahead and solve this again. We're going to use elimination. Sorry, I didn't need that line yet. I'm going to multiply this bottom equation here by -5. Okay, I'm going to get rid of my x term here. So that's going to be -5x minus 5y equals -25. Okay, so now this middle equation is gone. 5x minus 5x, that's going to cancel. 8y minus 5y gives me 3y equals 34 minus 25 gives me 9. Divide both sides by 3. Y equals 3 large cars. Okay, using the second equation, I know that x plus y equals 5. So x plus 3 equals 5. Subtract 3 from both sides. X equals 2 small cars. Okay, I like it. No any fractions or decimals to worry about, so we're off and running. Okay, last problem. A fruit company delivers fruit in 2 types of boxes, large and small. Sounds like the last one. A delivery of 3 large boxes and 5 small boxes has a total weight of 125 kilograms. A delivery of 9 large and 7 small has a total of 265. How much does each type weigh? Okay, so all kinds of stuff here. I got 3 and 5 equals 125. I have 9 and 7 equals 265. Again, let's going to go x. This time I have my x equal my large, just because I listed it first. Okay, and y is going to be small. And it doesn't matter, as long as you're consistent with what you call them and you get your equations right, you're going to be fine. Okay, so I know that 3 of my large plus 5 of my small had a total weight of 125. Okay, and 9 of my large and 7 of my small equaled 265. Okay, so we're going to go ahead and solve this again by elimination. So in this case, I'm going to multiply this top equation here by, well, I could multiply this by -7 and this bottom one by 5. I just soon stay away from that. I can multiply this 3 by -3 and get it to be -9. So let's do that. Okay, multiply this top equation by -3. That's going to give me -9x minus 15y equals -375. Okay, that equation is gone now. Okay, combining these two equations, the x's go away. 7y minus 15y is -8y. 265 minus 375 is going to be -110. Okay, divided both sides by -8. Equals 13.75. Okay, and again, this is a decimal, but that's okay. That's saying I'm just looking for the weight, and you can have 13.75 kilograms. Not a problem with that. It's not like you have 13.75 boxes. You have 13.75 kilograms in one small box. Okay. Now, let's go into that top equation. Why not? Okay, so that's going to give me 3x plus 5 times 13.75 equals 125. Okay, that gives me 3x plus 68.75 equals 125. Subtract 68.75 from each side. Please use a calculator on this. Gives you 3x equals 56.25. Divide both sides by 3, and x equals 18.75. Which, okay, again, it's a fraction, it's a decimal there. I feel okay about it because that's also supposed to be our larger boxes. Our larger boxes weigh more than our smaller boxes, and I'm okay with that. That makes sense. Okay, so there you go. A lot of information there, a lot of work. I'll tell you, 2 of those problems are very similar to the ones that you're going to see on your Unit 6 test. Okay, if you have any problems, go ahead and see me in class. Thank you.